So in this section, we're going to learn about LU factorization, and it is a type of matrix factorization. All right, so this is, if we have a matrix of a particular type, sometimes we can factor that matrix into two matrices that may be easier to work with. So let's suppose A is an M by N matrix. That says is. Okay, sometimes, not always, we can write it this way. A equals LU, where A is our original matrix. It's an M by N matrix. L is an M by M, so it's a square matrix, and it's also lower triangular. And we'll talk about what all this means. And then U is M by N, and it's upper triangular. All right, so we're factoring A into these two matrix components. All right, so let's look at some examples and we'll talk about what upper and lower triangular means. We've seen these before, especially upper triangular. This is the same thing as REF. So we got the zeros on the bottom. So all the stuff is on the top. Lower triangular, the zeros are on the top and all the stuff is on the bottom. Okay, here is our example. Matrix A. Going down the columns, it's going to be a 3 by 3, but just know A can be of any type of dimension. All right, so 3, -3, 6, -7, 5, -4, -2, 1, 0. So this is our matrix A, and it is a 3 by 3 matrix, which falls under the category of M by N. All right, then we have L. It needs to be M by M, so that means it needs to be 3 by 3. So down the columns, 1, -1, 2, 0, 1, -5, and 0, 0, 1. Right? 3 by 3. And then finally, we're going to have U. All right, this one needs to be M by N, so it needs to have the same dimensions as the original, so it should also be a 3 by 3. 3, 0, 0, -7, -2, 0, and -2, -1, -1. All right, so this is also a 3 by 3. So it just so happens all three of these are 3 by 3. And when you multiply these two together, you'll get A. All right, so why would we even want to do this? All right, let's talk about why. So question, why would we do this? Well, our goal in this class is mostly always solving linear systems. All right, so we have a system AX equals B. But according to this, we could actually rewrite A as L times U. So that's what I'm going to do. So instead of using A, I'm replacing it with L and U. All right, now let's look at the inside here. This U times X. This is going to be a column vector, right? And I'm going to give it a name. I'm going to call this vector Y. All right, so if I replace U times X with this random letter I've decided to call Y, column vector, we have LY equals B. But also, we need to define what Y is. We have UX equals Y, right? We named UX to be Y. All right, so now we actually have a pair of matrix equations to solve. So both of these together, now we have a pair of matrix equations to solve. Why would we do that? Why would we change our problem from only having one equation to two equations that we now have to solve? Well, because of the way that L and U look, lower and upper triangular, there are a lot of zeros in here. So solving with L and U are actually computationally cheaper than using this big matrix of A with very few zeros. All right, so this is actually computationally cheaper to solve. Especially for large systems. So when you're working in your field and you have a lot of data and you're solving really big systems, it may take a very long time for your computer to compute AX equals B. However, it'll be much quicker to compute these two smaller equations. All right, so in the next video, we're going to talk about how we're going to use LU factorization to actually solve this system.